Good afternoon, students. Today's video is going to take a look at polar graphing. We're going to look at an exploration that will help us review some attributes of trigonometric functions. Then we're going to take a look at how to graph a polar equation using a table of values. Then we explore symmetry of polar graphs, maximum and minimum values, and then we put all of the attributes together to sketch the graph of a polar equation without the use of a calculator. And so what we're going to do first is take a look at an exploration dealing with a trigonometric equation, as you see here on the screen. I have my calculator up because parts of this exploration do require us to look at the graphing calculator. It says, consider the trigonometric graph f of theta equals 2 plus 2 cosine theta. Use the graphing calculator to find the maximum value of f. What does this value represent? So I'm going to go to my graph, and here's the graph of 2 plus 2 cosine theta. And if you notice here, it's a function of x as I typed it into the calculator. And if you zoom in enough, let's do a zoom here. And we're going to do a zoom trig. And looks like this is the best it'll get us for zoom trig. As you can see here, I'll do one more zoom here. Let's do a zoom. Do a zoom fit. Okay, so as you can see here, I'm trying to get it to where you can see the max value. Of course, you can count, okay? I think that'll be a better view. As you can see, so the maximum value looks like it's at 4 there. So our maximum value of f based on the graph here is 4. And what does that tell us about this value? Or what does this value represent? So let's go back to the calculator again. As you can see, it's the distance from a minimum point to a maximum point, okay? The distance from the minimum point to a maximum point. That is what the value represents. So it's the distance from the max point to a min point. Okay? I'm boxing the word distance because that has some significance within this lesson. All right. Second part of the exploration says find the zeros of f algebraically on 0 to 2 pi, and then we need to talk about what these values represent. So we're going to set this equal to 0. And then we're going to isolate the trig function. So that gives us cosine theta equals -1. And so we need to determine the value on the unit circle. That gives us an x coordinate of -1. And if you recall from your unit circle trig, that's theta equals pi. And now we need to figure out what do these values represent. So if you look at the graph, it will be kind of challenging to tell where pi is. Okay, but you can guesstimate pi is about 3.14, so that's about right here. So that is indeed the x-intercept of the graph of f. I'm going to box in x-intercept. Again, that has some important significance within this lesson as well. And it says, describe the symmetry of f, and we need to talk about what this result means about f. So let me go back to the calculator again. And as you can tell, this has y-axis symmetry, because when you fold the graph around about the y-axis, the graph folds on top of each other. So we can say F has y-axis symmetry. And then this result implies that F is an even function. So we're going to box in y-axis symmetry. And we're going to box in F is an even function. And we can definitely tell it's even, that F is even, because the function involved is cosine, and recall that cosine is an even function based on what we talked about with identities. So all of this is important, leading into the concept of polar graphs. So by definition, a polar graph is a graph consisting of points, of a set of points, excuse me, with a distance of r units from the pole. So as you can see here, we have different types of polar graphs. You have circles, you have what we call limicons here. This is a special type of limicon called a cardioid. This is a limicon with an inner loop. If you come to the next row of polar graphs, this is a lemniscate. These two are considered rose curves. And this right here is considered the spiral of Archimedes. So these are some special type of polar graphs you will be coming across in this lesson. So now we're going to talk about how to sketch a polar graph using a table of values. So here, we're going to sketch the graph of r equals 6 cosine theta. So let's generate a table of values. Extend this further so we can have enough. All right. So we're going to make a table. In our first column, we're going to put theta. And then in our second column, we're going to put r. So what we're going to do is we're going to pick some r values. And for each r value, we'll compute, we're going to pick theta values. For each theta value, we will compute r values and then plot the point as we get it. You will, of course, need a calculator, because some of these numbers are not going to be too nice. They'll end up having some decimal approximations in them. So definitely need a calculator here. So we're going to start with 0 radians and make sure your calculator is in radians. And so when theta is 0 radians, you get an r value of 6. We're going to come over here. We're going to go 6 units from the pole. 1, 2, 3, 4, 5, 6. And there's our first point. And then we're going to pick next pi over 6. When you plug that into your polar equation, you're going to get 3 square root of 3, which is approximately 5.4 using a calculator. And so on the pi over 6 radial line, we'll go 5.4 units from the pole, is roughly right there. A little bit shy of the center. I'm sorry, from the middle. Then you'll pick pi over 4 as our next point. And when you plug that into your r value, you're going to get 3 square root of 2, which is approximately 4.2. So on the pi over 4 line, which is right here, radial line, we'll go 4.2 units from the pole. So 1, 2, 3, 4, and about 4.2, which is probably right there. And then pi over 3. Pi over 3 gives you a value of 3. So we'll go 3 units from the pole on the pi over 3 radial line. So 1, 2, 3. And then pi over 2, it gives us a value of 0. So that puts us back at the pole again. And so what's going to happen is you're going to continue picking points. And what's going to happen is you're going to end up getting a circle. That's what this these tables of values are going to get you. So we're going to start at 5 pi over 3 because what's going to happen is if I pick values in quadrants 2 and 3, they're going to give me negative R values, which will put me back over here and plot one of these points here again. So I'm going to start with 5 pi over 3, and when you plug that into here, you're going to get a value of 3. So at 5 pi over 3, it's 3 units from the pole. 1, 2, 3. And then at 7 pi over 4, we're going to get 3 square root of 2, which is 4.2. So here is 7 pi over 4. So 1, 2, 3, 4, and 0.2 units. Right here, you may notice some of my points are bigger. Sorry, that's too close. Definitely not 4.2. Actually, I plotted this point in the wrong place. So 1, 2, 3. Okay, and then here, 1, 2, 3, 4, and about 0.2, just somewhere right there. And then 11 pi over 6, you substitute that in, that gives you a value of 3 square root of 3, which is 5.4. So 1, 2, 3, 4, 5, and about right there, close to the middle. And then at 2 pi, you get back to 6. There's 2 pi, and you're back where you started. And so we're going to connect our points. And we have a circle. Okay. And that's drawing it by hand. Okay. Drawing it by hand. If you wanted to check yourself using the calculator, you're more than welcome to. But the point of this is to draw this using a calculator. So what I'm going to do first is I'm going to change this to polar and go back to menu real fast and click this equation off, and then go back to menu again for option 3, then 5, and then I'm going to type in 6 cosine theta. I'm going to press enter, and as you can see, we have a circle. Same position, same place, same size. Okay, so we did plot this correctly. So you don't want to plot the equation first and then plot the points. You want to plot the points first and then check it using your calculator. Okay, so if you understood that, here's a similar problem like the first one I just did. Go ahead. You want to generate a table of values. Kind of think about as you're plotting those points. Think about which theta values you want to use and which ones you shouldn't have to use. So now we get to symmetry. And so there are three types of symmetry when it comes to equations in polar coordinates. We have symmetry with respect to the polar axis, and that is if you change theta to negative theta and simplify the result and get the original polar equation, you know it has symmetry with respect to the polar axis. You have symmetry with respect to the line theta equals pi over 2. If you change r and theta to both negative, simplify the result, and get the original equation. You'll have that type of symmetry with respect to the line theta equals pi over 2. Or you can have symmetry with respect to the pole by changing r to negative r and simplifying the result to see if you get the original equation. So all three of these are tests you can use to determine what type of symmetry we have. There is a possibility we can do all three tests and they can pass or they can fail. In any of those two cases, then you'll go to the graphing calculator and see what type of symmetry it has. But sometimes the algebraic part of this could be misleading, but we will still use it anyway. So let's go on to our first example. So we have one here. All right, we're going to do 3 plus 2 cosine theta. So what I'm going to do is I'm going to check symmetry with respect to the polar axis. And what I'm going to do is change theta to negative theta and see what happens. So I get r equals 3 plus 2 sine of negative theta. And when I simplify that, I get r equals 3 minus 2 sine theta. And when I check it against the original equation, they do not match. So it is not symmetric with respect to the polar axis based on this calculation. Maybe it's symmetric with respect to the line theta equals pi over 2. Let's try that. So here I'm going to change both r and theta to negative r negative theta and simplify. So I get negative r equals negative 3 plus 2 sine of negative theta. And when I simplify that, I get r equals negative 3. And then here, you know, this will become negative 2 sine theta, but then when I divide by the negative r, it turns back positive. And you check r against the original equation, and it does not match. So it does not have symmetry with respect to the line theta equals pi over 2. Maybe it has symmetry with respect to the pole. So I'm just going to change my r to negative r theta and see what happens. So negative r equals 3 plus 2 sine theta. And I solve for r, I get r equals negative 3 minus 2 sine theta. And this does not match the original equation. So it does not have symmetry with respect to the pole. So we can't just rule out that it doesn't have any symmetry. Algebraically, it looks like we don't have any symmetry at all. But remember, I told you if it failed all three, then we need to go to our calculator and see what type of symmetry. So let's pull up our calculator and graph 3 plus 2 sine theta to see what type of symmetry it exhibits. I'm going to move the equation out the way, and as you can see here, this has symmetry with respect to the line theta equals pi over 2. And so by graphing, we concluded that R has symmetry with the line theta equals pi over 2. Can't say the y-axis because we're in polar mode and not rectangular. So you have to make sure you use the correct verbiage regarding the mode we're in. All right, let's take a look at the second equation. We got r equals 1 plus 2 cosine theta. So I'm going to do the same test as I did before. I'm going to check first with symmetry with respect to the polar axis by changing theta to negative. When I do that, I get r equals 3 plus 2 sine negative theta. When I simplify that, I get r equals 3 plus 2 sine, I'm sorry, used the wrong equation. 1 plus 2 cosine of negative theta, excuse me. When I simplify that, I get r equals 1 plus 2 cosine theta. Because remember, cosine is an even function. So the negative disappears and it still stays cosine. And if you notice, this is the same as the original function. So we know it has symmetry with respect to the polar axis. So I will convince you that the other two symmetries may or may not work. So let's try them. So if I do r theta and change it to negative r negative theta and simplify it, I get the following equation. Negative r equals 1 plus 2 cosine of negative theta. Simplifying, I get r equals negative 1 minus 2 cosine theta. And that does not match the original equation. So we know it does not have symmetry with respect to, it does not have symmetry with respect to the polar axis. So we'll check the last one just to verify. So we're going to change r this time to negative r theta. And that gives us negative r equals 1 plus 2 cosine theta. And solving, we get negative 1 minus 2 cosine theta, which is not the same as the original equation. So this indeed does have polar axis symmetry. And I will verify this with the calculator as well. So I'm using the calculator not to get my answer, but I'm using it to verify my answer. So I'm going to type in 1 plus 2 cosine theta. And as you can see here, it has polar axis symmetry for sure. This is the polar axis right here. So not only we verified it algebraically, but we verified it graphically as well. So as you can see, this procedure is not always certain to give us the answer. However, we can use these quick tests for symmetry. These quick tests for symmetry are going to help us later with regards to determining what type of symmetry a graph will have. So depending on the type of trig function we're using is going to depend on what type of symmetry we have. So if your equation just has sine in it by itself, then you know its symmetry is with respect to theta equals pi over 2, as you can see here. All right. Here, you can tell if a graph has polar axis symmetry if it's an equation involving cosine by itself. So once you know its symmetry, not only you'll be able to verify it graphically, you should be able to verify it algebraically as well. But again, just starting sometimes with the algebraic method won't always work. So here are the quick tests for symmetry. So here's some practice problems. I want you to try to utilize the 3 tests for symmetry first before using your graphing calculator, if all 3 tests fail. If you do discover what type of symmetry it has, then algebraically, then use your graphing calculator to verify your answer. So next thing we're going to do is talk about how to find max and min values of a polar graph. And so we're going to start with our first example, r equals 6 plus 12 cosine theta. So recall from unit circle trig and properties of trig graphs that the maximum value for sine and cosine by themselves are 1 and -1 respectively, okay? And we're going to use that information to determine the maximum value of each of these graphs. All right, so I'm going to start with first, r equals 6 plus 12 times 1. And that gives us a value of r equals 18. And then I'm going to check r equals 6 plus 12 times -1. That's going to give me a value of -6. And as you can tell, this is the bigger value, so my maximum value for this graph is 18. For our second polar equation, we're going to do the same steps. We're going to change sine of 2 theta, that includes the whole thing. We're going to change that to 1, and we're going to get a value of 3 here. Same thing with this one. And as you can tell, this is the bigger value. So therefore, our maximum value is 3. Reason why we're checking both values is it does depend on what's in the equation. Sometimes you can have a negative sign in here, and that could affect what the maximum value is. So if you understand those 2 examples, you should be able to do this one as well. These 2, the same way. So now we have arrived to the part of the lesson where we're putting all of this together. So now we're going to go back to sketching polar graphs again, but we're going to utilize 4 things. We're going to utilize symmetry. We're going to utilize max value, zeros, and a table. So we're going to put all of them together and be able to sketch these polar equations without the use of a calculator. Again, the whole point of this lesson is to sketch these by hand without using a graphing calculator. The graphing calculator, again, is a tool to help you check your answer. Before we get to sketching polar graphs, you need to understand some of the most common graphs that will show up here. And so we have special types of polar graphs. We have limicons here, okay? So you need to be able to identify when you have different types of limicons. When your A value is less than your B value in and it's less than 1. A is less than B. You divide A into B and get less than 1. You have a lemma sign with an inner loop. If A and B are both the same value, then you know it's a heart. When A and B are divided and you have a number between 1 and 2, you'll have a dimpled lemma sign, looks somewhat like a P shape or peach. And then when A divides into B and you get a number greater than or equal to 2, then you have a convex lemma sign. So you'll have to make sure you know these types of graphs. Then we have some Rose curves. You may come across these as well. You need to pay attention to the number in front of theta. If n is odd, you have that number of petals, okay? Like here and here, when n equals 3 and n equals 5. However, if your n value is even, then you double that number, and that's the number of petals you have. So if n is 4 here, you're going to have 8 petals like you see here. If n is 2, you have 4 petals here. And then on the last row, you see here you have some circles, you have some lemma skates. And pay attention to where the circles are located. So if your equation takes this form, your circle's on the polar axis. If your equation involves sine, then your circle's on the line theta equals pi over 2. You have a lemma skate here. This is this has symmetry with respect to the pole, and so does this. So these are the only two graphs. Lemma skates are the only two graphs that will have symmetry with respect to the pole. We come across. Okay, so with that information, we are able to go ahead and start sketching some graphs. The technique will be important, and of course, we'll check the validity of our graph when we are done using the graphing calculator. So here's our equation, r equals 1 plus 2 sine theta. So first thing we need to do is identify what type of graph it is, because that's very important. So I noticed that this takes the form a plus b sine theta, and I know a over b is 1/2, that's less than 1. So I know the graph is a lemma sign with an inner loop. I don't want to write too far into the graph. Need some room. Next thing we need to find is the symmetry. This is a function of sine alone, so it has symmetry with respect to the line theta equals pi over 2. So what I do is I draw a dotted line through pi over 2, so that way I'll know my graph is supposed to be cut in half through this line. So it's supposed to have symmetry with respect to this line when I get done drawing this graph. Third thing I'm going to find is the max value. You can do this mentally. So the max value is 3. Okay. And so we know that somewhere on this graph we'll hit the maximum value for sure. And then not finally, but the next thing we're going to find are the zeros. And we're going to set r equal to 0. And then we're going to solve this as a trig equation. And we're always solving this on the interval 0 to 2 pi. Okay? Because that's what our polar graph is based off on. So if you solve for theta, you get theta equals 7 pi over 6 and 11 pi over 6. So I already know that at these two angles, here and here, I'm going to be right there for sure. So that takes care of that. So now I'm ready to make my table. The table, I pick additional points that will help draw this graph. I'm going to sketch a table here. Now you don't want to pick values you found in number 4 because you already considered those. You already know the R value is 0 there. Okay. So theta and R. And then I'm going to start with 0. So if I plug 0 into my equation, I get 1. So on the 0 radial line, I'm 1 unit from the pole, which means on pi, I'm also going to be 1 unit from the pole. Now I'm able to use this line as a guide to help me get more points. So I won't have to plot a whole lot of points here. At pi over 6, I'm going to get a value of 2 when I plug that into R. So at pi over 6, it's 2 here. And at 5 pi over 6, it's also 2 because of the symmetry. Pi over 4 is the next angle I'm going to use. When I plug that in here, I'm going to get 2.4. And I actually use the calculator to get that value. So at pi over 4, I'll go 2.4 units from the pole, about right there. So that will be the same at 3 pi over 4, 2.4 units from the pole. At pi over 3, using a calculator, it gives me 2.7. So go 2.7 units from the pole, about right there at pi over 3, and that will be the same at 2 pi over 3. And then finally, I'm going to use pi halves, and I get the max value 3 here. Okay. Now I have to be careful here because this is a limit sign with an inner loop. So that means I don't have anything down here. I shouldn't have anything down here. My inner loop should be somewhere in here. So I need to figure out what's going on at 3 pi halves because that could be misleading. If I plug 3 pi halves in there, I get -1. And that is where the inner loop should be. Okay. So I have more than enough points to sketch this graph. So I'm just going to connect all my points here. And then I'm going to form my inner loop. And there you are. So now let's see how well we've done with using this in the graphing calculator. So I'm going to type in 1 + 2 sine theta. And looks like we have a complete match. Okay. Same shape, same size. So we did pretty good graphing this without the aid of so much the calculator. Now we did use the calculator, but we used the calculator to compute these values here. That's the whole point. All right, we're going to do another one. R = 2 sine 3 theta. And so first thing we're going to do is identify what type of graph it is. And so if you look at the form of the equation, you know it's a rose curve with 3 petals. And I know it has 3 petals because 3 is an odd number. So remember, if n is odd, then your rose curve has that many petals. Next, we're going to find the symmetry. So symmetry here, we got sine again, so we know it has symmetry with respect to the line pi over 2. So I'm going to go ahead and draw my line. Because that line's going to help me as far as symmetry is concerned. Three, I'm going to find the max value. And the max value here is going to be 2. And then 4, I'm going to find my zeros. So I'm going to set 2 sine 3 theta equal to 0. When you divide by 2, you get sine 3 theta equals 0. We have to keep in mind this is a multiple angle equation, so I'm going to box this in because that's going to be very important. Okay, so this is 0 when theta equals 0, pi, and 2 pi. But this is not theta, this is 3 theta. So I got to divide each of those by 3. So I get 0, pi over 3, and 2 pi over 3. So that means at these angles here, they all have a R value of 0. So those are taken care of. Now I'm ready to draw my table. And again, table is going to give us additional points to help us draw this rose curve. So first we're going to start with, can't start with 0. We already accounted for 0. So let's go to pi over 6. And if you plug pi over 6 in here, you get a value of 2. So at pi over 6, you're 2 units from the pole, which means at 5 pi over 6, you're also 2 units from the pole, because remember, you have symmetry with respect to pi half. Then we're going to go to pi over 4. Then at pi over 4, you get, when you plug that in for theta here, you get 1.4. So at pi over 4 here, you're 1.4 units from the pole, so about right there, give or take. Which means at 3 pi over 4, we get the same result. About right there. And then at pi over 2, remember at pi thirds it's 0, so we are skipped that, so go to pi halves next. Pi over 2, you get -2. So that means from on the radial line, I have to go 2 units in the opposite direction. So that puts the point here. So I really have found the location of my petals if I really think about it. And so I know it will probably be something right here. Okay. You want to convince yourself those points are there, you can plug those in. Okay. And so we're just going to draw a smooth curve here. You have a rose curve with 3 petals. Let's check our answer. See how well we did. 2 sine 3 theta. Again, same size, same shape. Again, looks like they match pretty well. Okay. All right. Last polar equation. Here, notice that we have r squared this time. So what we have to do is solve for r. So solving for r gives us plus or minus 2 equals plus or minus 2 times square root of cosine 2 theta. Okay. So based on the equation you have, you already know the only equation that has that deals with r squared is a lemniscate. Okay. We already know this is the only graph that has symmetry with respect to the pole. So what I'm going to do is not only, and that implies, that does imply that this has symmetry with respect to the line pi over 2 and symmetry with respect to the polar axis. It's both. Next, max value. Max value is going to be positive 2. And for the zeros, we're going to set r equal to 0. So that's plus or minus 2 times square root of cosine 2 theta. So what you can do is divide by the coefficient first and then square both sides, which gives you essentially cosine 2 theta equals 0. So remember, you got to, this is a multiple angle equation, you got to pay attention to that. Cosine 2 theta is an identity. If you want to use an identity, you can. Not necessarily, you don't have to necessarily use one. You could if you want to, but you don't have to in this instance. So here, the only angles that give you a value of 0 are going to be pi over 2 and 3 pi over 2. But that's 2 theta, not theta. So we need to solve for theta, and that gives us pi over 4 and 3 pi over 4. So we already know at 3 pi over 4 and pi over 4, we know they're both are 0 units from the pole. We know that. So now we're ready to draw our table. Let's draw our table. So theta and r. Let me write this a little bit higher, a little bit better so you can see it. Theta and r. All right, so now we can start picking values. So let's pick 0 first. At 0, when you plug it into r, you get plus or minus 2. So that means on 0, we go 2 units from the pole, and then we go 2 units in the opposite direction. Puts a point there. You can also use the fact it has symmetry with respect to the polar axis. Then power 6, you can use next. You'll definitely need a calculator for this computation. When you plug pi over 6 in here, you're not going to get a nice number. You're going to get 2 over square root of 2. But if you put that in the calculator, you get plus or minus 0.4. So that means at pi over 6, you go 0.4 units from the pole, so about right there. And for 0.4 units away from in the opposite direction, puts it there as well. But remember, this has symmetry with respect to the pole, so you got a point there, and you got a point there at these representative points. And there, and there. And I think we're ready to draw this lemma sign. Looks like an infinity sign. You can get ready to draw it. Not a rose curve. Make sure you be careful. This is definitely not a rose curve with 2 petals. It's a lemniscate. That is the correct classification. Now let's go ahead and put this in the calculator. See how well we did. So here you want to type in, I think we can do the plus or minus here, if it'll allow us. Let's see here. I'm going to go to the book here. Let me see if I can find it. We don't have that here. Yes, we do actually have it there. So plus or minus 2. And then we need the square root. And then cosine 2 theta. See what we get. Then draw anything for us. Okay, maybe it didn't understand it. So let's just get rid of that and see what it does. So it actually gave us that. So it gave us the correct graph. We just didn't need the plus or minus in. Okay, so I did 3 examples of graphing and using the calculator to verify each of those graphs. And so if you understood these 3 problems, you should be able to graph these same 3 problems using the same procedure I did. Again, make sure you utilize graph. Tell me what type of graph it is, what type of symmetry this has. Make sure you can calculate your max value, find your zeros, and then generate a table with additional points to help you sketch the graph. And then use the calculator to check your answer. So here's 3 sine theta. Here's 2 plus 4 sine theta. And here's 2 cosine 4 theta. And here's r squared equals 9 cosine 2 theta. Okay. So that concludes this part of polar graphing. If you have any questions, comments, or concerns, please feel free to contact me through the YouTube channel. Thank you and enjoy the rest of your day.